In any language we speak, verbs are the action words, right? They're what make things happen. Well, in the language of programming, those verbs are called operators. They're these tiny, simple symbols like a plus sign, a minus sign, or an equal sign. But they are the absolute foundation of everything a computer can do. So today, let's break down how these little symbols build entire digital worlds. I'm sure you've seen a formula that looks something like this before. Profit equals selling price minus cost price. It's simple, it's intuitive, and it also just happens to be a perfectly valid line of code. That minus sign right in the middle, that's an operator, and it's doing a job we all instinctively understand. But trust me, this is just the tip of the iceberg. So let's pause and ask, what are these symbols really telling the computer to do? I mean, how does a program go from a simple minus sign to calculating company profit, or making a split-second decision in a video game, or even manipulating the fundamental ones and zeros of a file? That's exactly what we're going to figure out. So here's our game plan. First, we'll nail down the basics of what operators even are. Then we're going to meet three distinct teams of operators. We've got the calculators for all the math, the detectives for making smart decisions, and finally, the insiders, the ones who work directly with the computer's native language of ones and zeros. All right, let's start at the beginning and build a solid foundation. What exactly are operators, and what do we call all the pieces when they're in action? To put it as simply as possible, an operator is a symbol that commands the computer to perform an action. That's it. A plus sign tells it to add. A minus sign tells it to subtract. It's a direct instruction. Take this data, do this specific thing to it, and give me a result. Okay, so when you combine an operator with the actual data it's working on, you create what's called an expression. Let's take 6 plus 3. The plus sign, that's our operator. The numbers it's working on, the 6 and the 3, those are called the operands. And the whole thing together, 6 plus 3, that's the expression, which the computer then looks at or evaluates to get the final value 9. Here's a really simple way to remember all this. If you think of code as a language, then operators are the verbs. They're the action words. And the operands, they're the nouns, the things the action is being done to. So add 6 and 3 is grammatically just like saying the cat chases the mouse. It's a simple sentence with nouns and a verb telling them what to do. Now let's meet our first team of operators. These are the ones we use for all our number crunching, the workhorses of mathematics in code, the calculators. Okay, most of these are going to look super familiar. You've got your standard addition, subtraction, multiplication, and division. No surprises there. But Python also gives us a few specialized tools for more specific jobs, things called floor division, modulo, and exponentiation. Let's take a closer look at a couple of these special cases. Now, this is a big one that trips up a lot of people when they're starting out. Python has two different ways to handle division. A single slash gives you standard, precise division. It will always give you back a number with a decimal point, what programmers call a float. But a double slash, that does what's called floor division. It does the math, and then it just chops off anything after the decimal, always giving you a clean whole number, or an integer. Next up is the percent sign, but hold on, it has nothing to do with percentages here. In Python, this is the modulo operator, and its whole job is to find the remainder of a division. So think about it. 10 divided by 4 goes in 2 times with a remainder of 2. So 10% 4 just gives you that remainder, 2. It sounds a little strange, but it has some really brilliant uses. And here's one of its most common jobs, a fantastic little programming trick. You can use it to instantly check if a number is even or odd. Think about it. Any even number divided by 2 has a remainder of 0. Any odd number divided by 2 has a remainder of 1. So with one single modulo 2 operation, you can instantly tell if a number is even or odd. It's an incredibly handy tool. Okay, so we've done the math. Now it's time for our code to start asking questions and making decisions. For that, we need to bring in the detectives. These operators are all about comparison. Is this value greater than that one? Are these two values not equal? And pay very close attention to that double equal sign. This is a classic rookie mistake. A single equal sign is for assigning a value, like x equals 5. But a double equal sign is for asking a question. Hey computer, are these two things the same? Now here's the crucial difference. Unlike the arithmetic operators that gave us a number as an answer, these detective operators give you a simple binary response. True or false? We call these Boolean values in programming. Is 5 greater than 3? The answer is true. Is 10 equal to 20? The answer is false. This simple concept is the absolute basis of all decision-making in every piece of software. And what's really cool is we can combine these true/false questions using logical operators like and, or, and not. So, for example, to get access to some premium content online, a user has to be logged in and is premium. Both of those conditions must be true. But to see an advertisement, maybe the rule is they are not is premium or on free trial. This is how we build complex logic and rules right into our programs.
All right, it's time for our final group. We're about to go from high-level logic all the way down to the very foundation of how a computer even sees data. So let's meet the insiders, the bitwise operators.
Now, this is where things get really fascinating. Bitwise operators completely bypass the decimal numbers that we're used to working with. Instead, they operate directly on the binary digits, the bits, that represent those numbers inside the computer's memory. They are literally working with the raw ones and zeros. And here they are. You'll see symbols like the ampersand for and that vertical bar for or. Now, I know they seem a little abstract, but they allow programmers to manipulate data at its most fundamental level. This is the kind of stuff you'd use in graphics programming or networking or anywhere that's squeezing out every last drop of performance is critical. This visual really helps make the process clear. So to calculate 1 and 3, the computer first converts them to binary. The number 1 becomes 0001 and 3 becomes 0011. Then it just compares them column by column. For a bitwise AND, the result in a column is 1 only if both of the input bits in that column are 1. So looking from the right, 1 and 1 gives us 1. The next column, 0 and 1 gives us 0. Then 0 and 0 is 0. And 0 and 0 is 0. The final binary result is 0001, which in decimal is just the number 1. And finally, you have these shift operators. They do exactly what they sound like. They literally take all the bits in a number and shift them to the left or to the right. And it just so happens that shifting all the bits to the left is an incredibly fast way to multiply a number by powers of 2, and shifting to the right is a super fast way to divide. It's a neat low-level optimization trick that's built right into the language. So there you have it. From a simple equation like profit equals SP minus CP, all the way down to manipulating individual ones and zeros, these different groups of symbols are the engine of computation. Every single action your software takes is built on a foundation of these operators working together in different combinations. So we've met the calculators, the detectives, and the insiders. They are truly the verbs of code, the tools that turn static data into dynamic action. Now that you understand the language of action, the only question left is, what are you going to build with it?